Hello everybody. In this video we are going to cover how to find an x value given a particular area or percentage given in the problem. So we're looking back at this is chapter 8 notes from Blackboard, and if you look at the top it actually says chapter 7, but in our book it's chapter 8. So this is chapter 8 book notes. If You look at this problem, it says, for example, what if I want to know the range that the highest 15% of temperatures fall in October? This is that same Bowling Green problem. Okay, we've worked a couple of these in the previous videos already. So the same mean, same standard deviation. And we're looking at the highest 15% of temperatures. So as this problem depicts, this would be the top 15%. So given that that is the top 15%, then we say to ourselves, okay, then what is this area? And since we know the entire curve adds up to 1, okay, 1 second, let me get my pen here. Since we know the entire curve adds up to 1, we can do 1 minus 0.15, which is going to leave us with this other blank area right here being 0.85. So this area is 0.85. Okay. That's because this area plus this area always have to equal 1, okay, for the entire curve. So we're looking for, in all practical purposes here, what they're really asking is, what is the x value that sits right there that outlines that 15%? Okay. Now, to do this by hand, or we're going to do this by hand first, and then later on in the video, I'm going to show you how to do it in the calculator. So to do this by hand, we need a z-table. Okay, so I'm going to go to our Blackboard shell under course content. Again, pull up our formulas table. Okay, I'm going to scroll down here to where the z-tables are. And let's zoom in here a little bit. Okay, what we're actually looking for here, give me 1 second, is the score that's going to outline. Now remember, this table only gives you areas to the left, and I talked about that before. Only areas to the left, only areas to the left, okay, to the left. So if we think about the problem that we're looking at, the area to the left here is 0.85, okay, 0.85. So in this table, we want to find or get as close as we can to 0.85. And that's in the body of the table, okay, in the body of the table. And if I look at the numbers here, they just keep going up and keep going up, and I follow them until I get to, looks like 0.8485, and then it goes 0.8508. So we're going to pick the one that's closest. There's not a perfect one in there. We'll pick the one that's closest. 0.8508 is our closest one to 85%, or 0.85. So we're just going to read off the score that corresponds to that z-score right there. So that is 1.04. If we look over here is the 1.0, so 1.0, and then where our score is in the column that's 0.04, so that's 1.04 is the z-score that would give you as close as you can get to 85%. So we come back to our notes here. We see that is listed right here. That's 1.04. That's your x value. That's the z-score that corresponds with that x value. So what we have to do is basically work this by hand, and it shows it right here, but I'll go ahead and work it for you again here. We have basically, I most of the time write it in this order. The x that we don't know minus the 71 that was your mean for this problem, divided by the standard deviation, which is 4, equals the z-score that we got, which is 1.04. Okay, so we're basically solving this problem for x. Okay, so the first thing I would want to do is clear out this 4 that's down here, so I'm going to multiply both sides by 4. That will give me x minus 71 is equal to, and then 1.04 times 4, if I were to multiply there, it's going to give me 4.16. Okay. Last step, we're going to add that 71 to the other side. So adding 71 to 4.16 gives me 75.16, which would be the score, or the temperature in this case. That 75.16 is the temperature that would be the lowest bound for the top 15%. So anything that was 75.16 degrees or more would be considered the top 15% of temperatures in Bowling Green in October for this same problem. Again, these are from your notes. Okay. Now, if we want to do this using the calculator, it's pretty simple. And let me show you here. What you're going to be looking for, again, this is your calculator page. It's the very next page after that, is the inverse norm. Okay, it's in the notes right here, and I'll walk you through how to do that. So if we go to the calculator, what we are looking for is, again, underneath that distribution, vars. Okay, it's the vars button, but we want the distribution menu that's above it. So second, distribution. Now what we're looking for here is the inverse norm. Okay, that's the function that's going to do this for us. So we select number 3, and it says what is the area that we're looking for. And again, just like the normal distribution table, okay, that we have been using, just like the normal distribution table, the calculator wants areas to the left. Okay, it's always areas to the left that we're getting or we're looking up. So using the technology here, the area to the left of that line, okay, the area to the left of this line right here, the area to the left, we always have to put that in, is 0.85. Your mean here is 71, standard deviation of 4. So we're all set up here. Okay, just type those in. Go down to paste, hit enter. Now, if you've got an older calculator that doesn't do these pop-up menus, you select the inverse norm function, and then we're going to type in the area to the left, comma, mean, comma, standard deviation, and then we hit enter, and there's your 75.14. That is the exact same answer that we got right there, sort of. Now, you notice there's a little bit of difference. We got 75.14, basically 0.5 if you round it correctly, 75.15, and by hand, we got 75.16, and that's okay. We didn't make a mistake. The table that we use here can only get so accurate, and if you remember, when we were looking up 0.85%, we didn't get exactly 0.85%. We got 0.8508. And there's where the discrepancy comes in. Now, your homework online and any problems that we do, they should allow for both answers. Okay, they should have a leeway in there for both answers. So whether you do it by hand or whether you do it in the calculator should not make a difference. Okay. So that's finding an x value given an area, okay, by hand and with calculator. If you have any questions about this, again, just email me. Y'all have a good day.